So I will ask Laura, Antoine, and Archisman to come back on stage. Chair should be provided. Yeah. Okay, now we have a panel discussion. So we haven't organized anything in the details, but we have at least a couple of questions to start with. But before we do, the two questions are mainly going in two main directions. One is data analysis and theory. The other one is observations. So let's have a quick poll. Who is for data analysis and theory? Okay. Who is for observations? Fair enough. Then we have our answers. So one of the main questions that, one of the two main questions that was this is how are observations going to evolve? So Archisman already gave a nice overview of current observation and how they're evolving in the future. And Antoine completed that with the low frequency regime. I think we are not going to ask when is the next PTA data release. But is there any question that people may already have in the audience, maybe for people, for the panelists, let's say? Otherwise, I will go with always my favorites. If not, maybe we can start with the ground-based observation, given that Archisman went first before. So you already gave a nice overview of, let's say, LIGO and Virgo, how they're going to evolve in LIGO and Virgo Ash, no, LIGO Ash and Virgo next, let's say. So how can you explain a bit? Maybe you didn't say this in the talk. During all this timeline, let's say, from, let's say, current second generation detector to fully third generation detectors, how is it going to evolve exactly? Is this something that is already fixed, or it's something that it's not fixed? So we know that there is a next phase of LIGO and Virgo, but is this supposed to overrun with the third generation, or is something that
Indeed, this is not fixed. So how long the timelines for the time scales for this post-O5 LVK is not fixed at the moment. That's why whether they're going to run in parallel with 3G is also not fixed at the moment. So from on the European side, we have some concrete timescales, although they're a bit still very optimistic about plans of when Einstein telescope is going to be launched on paper. If you see, still the launch date is 2035, which is rather on the optimistic side. But still, we expect that if not 2035, 36, 37, ET will start operating. On the CE side, I'm not sure if there's any CE member here who's able to add to what I say. It's still, I mean, it's, I believe, I personally think there will be at least one third generation detector in the US. Still, there are questions about whether it will be a 20-kilometer, whether it will be two 40-kilometer ones or one 20-kilometer one and a 40-kilometer one. So a part of the post-O5 upgrades is also to bridge the gap between the current detectors and 3G. So I would understand that the post-O5 upgrades keep running until the 3G detectors become operational and they make the LIGO Virgo upgrades unnecessary to operate in longer. That's my understanding.
Take the microphones in the right. There are people on Zoom.
Just when Cosmic Explorer is planning to start, it's the same time schedule as for ET, or?
I don't think they have a time scale attached at the moment.
Does ET have a time scale attached?
ET has a time scale attached. The start date on paper is still 2030. The time scale on paper is site selection by 2026.
That was my next question when you say selection.
Start of construction by 2028, 7 years of construction, 2035 for the start of ET taking data. But this is very optimistic. This is very optimistic. Site selection, almost everybody will say will take more time, and depending on whom you ask, it may be a bit more time or a lot more time. But we expect it to slip by maybe 1 or 2 years, not by a decade, or not by half a decade, I think.
Okay. So, yeah, we cannot give an estimate, let's say, for the moment. Yeah. Can you give?
I have a yes, it works. I have a question sticking to, let's say, current generation observatories. There's this whole challenge to have multi-messenger observations, which is important. And I was curious to see if there's any plan for the current, or maybe LIGO A# and the advanced versions to be running for like long periods of time, so that there's a duty cycle that is big, and we can hope to have multi-messenger detections in larger numbers even before we get to the new generations.
So for multi-messenger observations, the most important thing we need is to have at least 3 detectors operating at the same time. Unfortunately, this was not possible for the first half of, for the first part of 04. But I mean, as soon as Virgo joined, the sky area started shrinking considerably. So as a community, we should try to ensure that we have 3 detectors worldwide operating in a network all the time. This is the plan for 05. That's the main thing that we'll need for multiple detectors.
For Virgo, are you planning to change? For example, there is a major problem that comes from the size of the detector itself, and for 05, are you planning to change that, or it will, because there were some issue with the fact that it's barely stable, the resonance in the cavity. So are you planning to change that for 05 or not?
Okay, this is about stable recycling cavities, and the idea is to have I mean, at the moment the plan is still to have 05 with stable recycling cavities.
I think there is someone on Zoom that maybe can jump in.
Yes, hi, I can say maybe something more about stable.
Susanna, go ahead if you want to say something.
Can you hear me?
I think we are supposed to hear you, but we don't hear you.
Okay, I can.
Now we hear you. Go ahead.
Fine, I can hear you very well. So I can say something about stable cavities for Virgo. The collaboration is study the design, and in principle, we should have a final decision by this July. And then we should have this tough plan to implement them so as to be able to join reach at least a part of 05. There are discussions also going on with LIGO to see if we can tune the 05 stars so that Virgo can participate to most of it. But I think that now the critical point is really to make decision this July. And in this case, things can be good for Virgo to join at least a large part of 05. And instead, if they don't come they are not able to provide the documentation needed for the decision in July, this is so for spring, and then to have the the council decision in July, then it will be much more risky for 05. So this is the situation.
What about the Indian LIGO? What is the status? Because you show on your graph that there was also Indian LIGO, and sorry, maybe.
Yeah, I'm not fully up to date. Although I was in the LIGO India community a while back, I'm not very closely up to date. So construction has started, and it's things go a bit slow tend to go a bit slow in India, but still the plan is that they should be ready by the time we get to by the time the current detectors go to post 05 sensitivities.
Yeah, I'm sorry, just coming back to my previous question, I was maybe wondering if there's any plan to have, say, something crazy like a 10-year 05 run. If we know we're not upgrading after some point, do we plan to keep the detectors running until we have ET or Cosmic Explorer? That was what I was curious about.
Yeah, but 10-year is by 10 years, beginning post of by 10 years.
Or I mean, anytime until we get the new generation of detectors, basically.
At 05 sensitivity or with post 05 sensitivity?
I was wondering at 05 sensitivity,
At 05
I guess.
sensitivity.
I mean, I'm not sure. You tell me.
I'm not sure. I see 05 is going to go on for a few years, quite a few years. Let's say 4 or 5 years, 4 years. But I mean, after that, it also makes sense to go to higher sensitivities than that, right? Take a commissioning break and increase the sensitivity further than 05. There are probably people who would like to comment here.
Thank you.
I'll let them comment.
Maybe a very short comment on that is like the backup of the backup scenario, that if there will be only one 3G detector earlier than, so maybe Einstein telescope before Cosmic Explorer, and there is nothing better than 05 sensitivity, then it will be great to have at least a three detector network with one 3G and two, let's say, 05 detectors. This has been considered. There are some, let's say, some science estimates of what you can do with that, and it's not bad at all. So yeah, this is a good idea. But I think at the moment it's the backup of the backup of the backup scenario. Probably, yeah.
And the last one, Kagra. When is this?
Do you want to take it?
1 second now. See, Kagra suffered a very unfortunate incident last year after earthquake. It was not able to recover sensitivity. But I believe Kagra should be operational by again in 05. It's very difficult for me to give the most up to date.
Well, the latest news I got is that, I mean, the problem they have is mainly with the cryogenic technology. They don't manage to reach the actual temperature they want to reach, and at slightly higher temperature, not everything works as they want. So they actually don't have the sensitivity at low frequency. What I believe they are trying to do is to solidify their sensitivity at high frequency so that they can work as a normal, let's say, second generation detectors with a sensitivity which is a bit less than Virgo. And this is probably what they want to at least do for 05. Hopefully, by then also the cryogenic technology will work, so they will have more sensitivity. But for 04, the maximum they can go, it's optimistically 10 megaparsec. So it's quite low. Okay, any other questions for ground-based observation? Don't know, we can do the same game with, let's say, space-based and moon-based and pulsar-based. Can you put a timeline on all these observations, or at least
the timeline on Lisa?
Lisa, we know. So what's
2035.
But is there a plan apart 2050, Voyage 2050?
Maybe in the context of Voyage 2050, for Luna, for the Moon's project, it's opportunity project. So given all the Artemis program at NASA, given all the mission, so there are a lot of let's say a lot of motion to have project on the Moon. After we need to see what is realistic in terms of sensitivity. We need to prototype the thing, so it's, I would say, not before 10 or 20 years, this kind of project. It's just but we need to maintain the R&D and to continue developing this project, but I don't think we will get something before yes, but if it's just seismometer, the seismometer thing, we know how to do some they were just a simple project that was doing SAIS, the seismometer that was on Mars, just on the Moon. The same team proposing just few seismometer, everyone on the Moon, and use the Moon as a resonant bar. But if you use the Moon as a resonant bar, you have a very limited frequency because it's just the resonance of the Moon. So you have, it's like having a bar of 300. I don't remember the size of the Moon, but yes. And for the other project,
like atom interferometer?
Atom interferometer, they first need to do that on ground. And there is this at least two projects, this ION project and this MIGA project. MIGA, they start commissioning. So they, maybe Laura, you know a bit, no. It's Paris Observatory, but so MIGA, they start to commissioning. They are, I think they will finish the building by the end of the year and start commissioning really the detector. So it's, this detector won't be able to detect gravitational wave because it's too short, but at least it will test all the technology of atom interferometer in let's say the size of a typical detector. So I think atom interferometry will come quite soon, and they have a plan. And it's also because it's not only interesting for gravitational wave, but it's also interesting for searching for dark matter. They have a lot of science case. So I think, well, if I have to bet, I would say atom interferometer will arrive quite quickly. In space, we will have Pharaoh, the first atomic clock in space that will arrive soon. So we'll see if an atomic clock can survive in space, and we'll learn things about that with Pharaoh. But after we will have to go for.
But the sensitivity you were showing for like ages like 1 kilometer and so on, that's on the Earth.
Yes. Yes.
They were already quite good. How much? Yes. How realistic are they?
MIGA and ION 100 will be 100. So it's more what will arrive in the next years will be ION 100, and it's, you may have some if you have a very strong event in at the DCRs, you may detect for like a merger of intermediate mass black hole that we don't know if they exist, but if you have a binary of two intermediate mass black hole very close, yes, MIGA can see that, and ION 100 too.
Great.
I think.
Any question from Antoine? Yeah. We have the other. Next.
Lisa Max is L5, L6. L6.
Just a quick question. What is L4? Did you say has already been selected?
I think it's the explorer of the giant ice. So it's Uranus, Neptune, and this kind of thing.
Okay.
I think.
Yes, if you talked about it, I missed it, sorry, but there are little like Chinese instruments.
That was my next question.
Because in the science case, it could be very important for finding conflict.
Yes, so there are, I don't remember the two names, but there is two concepts.
Taiji and Taikin, I don't know how to pronounce them.
And so there is one that is LISA-like, almost the same as LISA. So, and the last time I heard about that, it was 1 year ago, and they say that their timeline is more or less the same as LISA, maybe a bit, maybe 1 or 2 years later. But they still have to choose between the two projects that they have. There is one project that is LISA-like, so the same size as LISA, and the other one is something around the Earth. So not the same size of the arm, so it's more in the decihertz range. That's true. And they are facing some complexity due to the fact that they are orbiting around the Earth in a polar orbit. And then at some point, the sun is in the axis of the triangle, so they have to rotate the spacecraft. And it's very complex to be around the Earth compared to be far from the Earth. But if we can have two LISA-like objects, that would be fantastic for science. In terms of sky localization, the sky localization would be fantastic. And we can even disentangle if we have background, cosmological background, etc. We can be sure that it's not due to the instrument, but it's really gravitational wave, etc. So having the Chinese mission at the same time as LISA will be very, very nice.
Having the data of the Chinese.
If we have the data sharing.
Slightly linked to that, I mean, if the Chinese mission comes a few years later, but LISA has only a finite lifetime. At least you mentioned the default mission duration, which was surprisingly short. So is there an onboard limit on the lifetime of LISA, or is this just ESA funding default lifetime for the moment?
The lifetime of 4.5 years, it's what NASA can guarantee in terms of lifetime for the laser. But we know they can guarantee that they will survive at least 4.5 years. So this was the limit of 4.5 years, but we know that laser can survive longer in space. So that's not a strong limit. There are two other limits that is more, that is 10 years of mission. It's due to the fact that the triangle, so the position of the triangle is chosen to be as far as possible from the Earth, because the Earth, if it's too close, it will destroy the triangle just by gravitation. One spacecraft is attracted sometime more than the other, and the triangle will be unstable at some point. And if the variation between the two spacecraft is too large, you are not anymore able to do the interferometry correctly. So this is one of the limitations. The orbit show that we may pass this 10-year limit. And the other limitation was, the other limitation is the propellant for the cold gas. So it's the cold gas that we have on board. And this is really related to the balancing of the spacecraft. So because one of the main, okay, maybe it's a bit technical, but you have the test mass and you have the spacecraft around the test mass. If the spacecraft is very well balanced, so it means that you have enough mass to attract the test mass from all the parts of the spacecraft in the same way, the consumption of cold gas is very low. If you have more mass at some point of the spacecraft attract the test mass and you consume more propellant. So this will be very dependent on the balancing on the spacecraft.
Thanks.
Any other question for space? One from very far in the bottom.
Question about the US contribution to LISA. Do you have any US free solution in case of the loonies in the White House decide to cancel the
At the moment, no news. We continue as we are, but we know that there are some reduction in term on science. We don't know exactly what does it mean. We don't. The key part is really the contribution for the telescope and the laser that are provided by NASA. That will be critical. if we have to do that in Europe, we have a few years delay easily, and we need to find the money because in terms of expertise, we know to build a telescope in France, for example, on Germany know to build a laser, but if we completely lose the US contribution, that will be hard. It's 20% of the mission, but it's two key aspects, even if not only the US know to do that, but it's two key aspects, and that will be complex. In terms of ground segment and in terms of science, it's unfortunate, but the DDPC is constructed to operate without the NSGS in case the NSGS cannot work. There are two independent centers. We have two for redundancy and two cross-checking, but having one already is good. And after it's the science exploitation. But no news, and we hope it will go okay.
There's another question. Then maybe we can move on to another subject.
So just following on actually from Fabian's question. So you said the lasers are one of the limitations, and obviously in space, if something breaks, you can't fix it. Are there like redundancies, or is there literally one laser, or do you have like backups if one hardware failures on launchers?
We have for each MOSA, so for each tube that and we have 6 tubes like that, we have 2 lasers.
Okay.
And initially it was one nominal laser, one non-redundant, and in fact we will switch between the two lasers every 6 months. So we have 2 lasers, and if one is not working, we can only use one, but it's not a problem. We can so we have redundancy for the laser.
Sure. And in terms of like extended life, like Hubble is now running on like 1.5 gyro that's limping or something, I think, isn't it? If you lost one completely, so you ended up with a 2-arm or something system, can LISA continue to operate? Potentially, can you still get useful science out of that, or is it reliant, the limiting factors, as soon as you lose one of the arms?
If we lose one of the arms, we can still operate, but with a reduced sensitivity. We will lose a lot of precision in terms of sky position, in terms of the ability to measure the distance. It's like if we, an easy way to see that, it's we can measure just a combination of the 2 polarization instead of measuring the 2 polarization with the 3 arms.
Sure. I mean, it's still better than nothing, right? So it's worth
it's better than nothing. And the
yeah.
initial LISA that was 20 years ago, the idea was to have the 3 arms for 6 months only, to count the 3 arms for 6 months and to operate with 2 arms. At the end, we realized that we need the baseline should be 3 arms for the full duration of the mission. But there are combination of laser that we call PDI combination that can work with just 2 arms, but we lose 1 channel.
Sure.
Instead of having 2, we have only 1.
That extends the possible life even longer, essentially, then, but in a limited way. Okay.
I think we will. At the moment, we are in an ESA context, and they want to guarantee that the mission is working. So when we are asking, maybe we should guarantee that this kind of, they say no, but we will find some way when
exactly.
Will be fine.
Okay, we are almost at the end. I just wanted to maybe discuss briefly multi-messenger observation, since I mean, half of the audience is probably interested in this. And starting with Laura. How much do you think waveform modeling will influence the ability to detect, or let's say, to localize sources in the sky? Like, for example, adding all new features like higher modes, precessions, and so on into waveform will be crucial in the future, like for 3G detectors and so on. LISA, for example.
Well, I think it would be crucial because we will detect more and we need better modeling. In particular, I think these effects are very important, especially for any detectors, I think, because especially for multi-messenger detection. I don't know if it improves the opportunity to have a multi-messenger detection. I don't know.
Well, it will improve the sky localization quite a bit, but my question is, how far away are we to have, let's say, a fully processing model, waveform model, in terms of theory? Far. Yeah. If you add eccentricities, you add spins, yeah.
No, fully processing, I don't know. I think we are not so far. I think there are many people working on it, and I think it should be done like by 10 years.
Okay.
Yeah, on the modeling, I think people are working on it, and I think they will be do. I think the most better thing that we can do also for these events, especially for LISA, is environmental effects, taking into account that supermassive black holes are with a dense environment that can affect the wave. Or maybe that's where most improvement can be done.
Which will even be more interesting for multi-messenger observation in case.
Yeah,
that's a good point. Any question for Laura? We'll try to finish soon.
Well, more than a question, is a general comment. I would think that in the era of Einstein telescope or whatever, at least for the binary neutron star mergers or whatever, the multi-messenger possibilities, not just probably for the sky localization, because if I understand correctly, with just one big detector will not be that much, but unless they are significantly continuously below, let's say 100 or a few tenths of degrees, the experience now suggests that it's quite hard. Probably our best hope is, for example, tomorrow we will discuss is for GRB detection. If it will be really possible to detect that these mergers up to redshift 1 or beyond, we already know, unless we are screwing up everything, that there are tens of such GRBs per year. And once we will have the proper satellite missions like we have now, even for the next 10, 15, 20 years, then the chances will be really, really high.
Okay, thanks. Any other comment? Otherwise, quickly, maybe Artisman and Tuan, multi-messenger perspective of 3G and LISA. What should we expect? I mean,
okay, for 3G perspective, one thing that is very exciting is because of long signals, early warning, getting to know even before the BNS is actually merged. Enough, in some cases, even enough time for the telescope to slew a long way and point the right direction, be ready to observe.
probably an uncomfortable question. In terms of probably an uncomfortable question, but in terms of sky localization, is it better the triangle or the
In terms of sky localization, separated detectors are better.
Okay.
Better. You have to, if you assume that only the ET will be operating, then definitely separated detectors. One with the just triangle at one point, the sky localization will not be as good as.
Okay, but you need two detectors far away, let's say one in Europe and one in the south of the world, or two in Europe are enough?
See, ideally, it would be best. It'll be better if you can have them as far as possible, right? But for ET is a European project. ET is bound to be a detector or a set of detectors in Europe. So this is the maximum baseline that you have. I mean, we'll certainly do better if we are operating. As somebody also mentioned this after my talk, that we should think of operating together with Cosmic Explorer. So that's really also the key for multi-messenger astronomy, working together as a global network.
Yeah, great. Antoine, you already touched about multi-messenger observation, you're told.
Touch a bit, and it's really supermassive black hole binary, one of the key sources for multi-messenger astronomy. And one of the problems with multi-messenger with this source is the model for the counterpart, the model for the electromagnetic emission is unclear, and there is a vast range of model, and it's complicated. We will try to do in LISA. We are pushing to do our best in terms of having something as soon as possible, because we think that if we can have something pre-merger, if we have a kind of a localization pre-merger, a good localization before the merger, it means that we may find some feature in this sky localization that have the same periodicity as the source. And in this case, we can really guarantee that we observe the same source. Post-merger, it's more complicated because you need either to go back in your data or you need to find something new in this position of the sky. So it's complicated. And after we will have other source, tidal disruption event, but I think the perspective is not that big in terms of counterpart and gravitational wave. Yeah.
All right, thanks.
I have one question for Antoine that I
Go ahead.
came up during some
I was about to
discussion.
ask the
When you
last
talk about
question.
the Chinese detectors, I mean, is it possible that if the Chinese detector comes up late after Lisa is at the time when Lisa is going down, that you combine the 5-year run period from Lisa and the 5-year run period from Taiji or Tianqin into a 10-year run period? You pick up the sources where Lisa left it.
For the galactic binary, yes, we will learn a lot on galactic binaries if we have 2 separated missions. But for the supermassive black hole binary, the source is few months. So in few months, if you have 2 missions separated by, or if you are not observing simultaneously, you don't gain anything.